Assalamu alaikum. My name is Sira Najaf and my roll number is 21TE06. Today, I will be discussing Lab Manual 1 of Digital Signal Processing, which is the basic plotting of signals using MATLAB or Octave. The lab objectives are: explain digital and importance of digital data in context of sort, search, store and transmit. How to plot signals. Writing scripts in MATLAB or Octave. Creating and calling functions. Task number 1 is, in the context of digital signal processing, elucidate the essence and intricacies encapsulated within the term digital. So the answer is that in the context of digital signal processing, digital refers to the use of digital values, typically in binary form, to represent signals. This involves converting continuous analog signals into digital form through processes like discretization, quantization, and sampling. Digital signals are represented using binary digits or bits and can be processed using efficient algorithms. The advantages of digital signals include robustness against noise, ease of storage, and transmission through digital media. The key intricacies involve the precision of representation, balancing between precision and efficiency, and the application of mathematical algorithms for digital manipulation and analysis. Answer of task 2 is, in digital signal processing applications, the choice between linear search and binary search illustrates the relationship between digital data and sorting, with implications for data processing efficiency. Linear search. Description. Linear search involves sequentially checking each element in a list until the desired one is found. Relationship to digital data in DSP is that linear search is analogous to scanning through data sequentially, which is often suitable for unordered or unsorted data sets. Implications for efficiency in linear search is simple to implement but can be inefficient for large data sets. Its time complexity is O(n), where n is the number of elements. In DSP, it may be suitable for situations where the data is not sorted or when the cost of sorting outweighs the benefits. Moving on to binary search. Description. Binary search is a more efficient algorithm that works on sorted datasets by repeatedly dividing the search space in half. The relationship to digital data of binary search mirrors the efficiency gained by organizing digital data in a sorted manner. It leverages the order structure to quickly locate the desired information. Implications for efficiency in binary search has a time complexity of O log n, where n is the number of elements. In DSP, it is beneficial when dealing with sorted data, as it significantly reduces search time. However, sorting the data initially incurs an additional cost. Implications for data processing efficiency are sorting overhead, preprocessing considerations, and algorithmic efficiency. Moving on to task number 3. In the domain of digital data, what strategies and techniques can be employed to enhance data transmission efficiency? Answer is, in the domain of digital data, the enhancing data transmission efficiency involves employing various strategies and techniques. The first one is compression, second is error detection and correction, third is data packetization, fourth is multiplexing, fifth is forward error correction, which is also known as FEC. Sixth is modulation techniques, 7th is transmission protocols, 8th is parallel transmission, 9th is bandwidth management, and 10th is protocol optimization. To task number 4. In task number 4, we are given a code snippet and we are asked to observe the effect of changing frequency, effect of changing time, and what is the relationship between time and frequency. So I will be performing this on MATLAB. So when we run this code, we observe a simple sinusoid ranging from the time 0 to 1. But if we change the frequency from 1 to 2 and then observe the graph, we see that the frequency has doubled. And if we change the time from 0 to 2 and then observe the graph, we will see in the time axis the time has changed from 0 to 1 to 0 to 2. So the relationship between the time and frequency is of an inverse. Moving on to task number 5. In task number 5, we have been given the code, and the code is about adding title, labels, and axes bound to the signal graph. Then we have been asked to change the axis function parameters and note the observation, and to change the title and labels and check the output. So when we run the code, we observe this graph. But if we change the axis parameters, and then run the code, we will observe that the graph has changed. Simply, if we change the X label, Y label, and title, we will observe that in the graph, these things have also changed. The X label, Y label, and title of the graph have changed. Task number 6. In task number 6, we have been given the code, and the code is about plotting multiple signals in the same figure. If we run the code, you observe that there are two signals, signal 1 and signal 2, of different frequencies and different time, but they are in the same plot. Moving on to task number 7. In task number 7, we have been given the code, and the code is about plotting multiple signals in one figure without connecting dots. So when we run this code in MATLAB, we see that the two signals, signal 1 and signal 2, are plotted in the same graph, but they are not connected. In this code, we have used the term hold on so that we can plot two signals in the same graph. Task number 8 is about generating random data from a uniform distribution. In this code, n is the number of samples, r is the function, and we use the term plot to plot the function r. So when we run this code, we see that a mean of random uniform data has been plotted. Moving on to task number 9. In task number 9, we have been asked to make a function with the name mymin that takes a vector as an input and returns the minimum value of that vector. So we have taken a vector whose length is from 1 to 10, and we have made a function with the name mymin. So when we run this code, we see that the minimum element is 1 in the whole vector, and it is displayed in the command window. In task number 10, we have been asked to make a function myMax that takes a vector as an input and returns the maximum value of that vector. We have taken the vector from 1 to 10 and we have made the function myMax, and when we run this code, we observe that the maximum element in this vector is 10, which is displayed in the command window. In task number 11, we have been asked to make a function myAverage that takes a vector as input and returns the minimum value of that vector. Here we have taken a vector with length 0 to 10 and the function as myAverage, and when we run this code, we see that the average of the vector is 5, which is shown in the command window. In task number 12, we have been asked to make a function mySort that takes a vector as input and return the sorted vector. Here we have taken the input vector and next we have made the function mySort. So when we run this code, we see that the input vector has been sorted, which is shown in the command window. In task number 13, we have been asked to make a function myReverse that takes a vector as input and returns the reversed vector of the given input vector. Here we have taken the input vector and we have made the function myReverse. So when we run this code, we see that the given vector, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, has been reversed and it is shown in the command window. In task number 14, we have been given the code, and in this code we can draw multiple plots in one figure using the subplot function. So when we run this code in MATLAB, we see that there are two graphs in the one figure because we use the term subplot. In task number 15, we've been asked to make a function win4 that displays 4 plotting windows in the same figure. Here we have made the function win4 and we have given 4 signals with different frequencies. So when we run this graph, we see that in one figure there are 4 graphs with different frequencies. The plot number 1 has 1 frequency, 1 Hz frequency, number 2 has 2 Hz frequency, number 3 has 3 Hz frequency, and number 4 has 4 Hz frequency.